As far as we know, there's only one world in the entire universe that is definitely alive: Earth. We searched Mars. We stared into the poisoned skies of Venus. We listened to the frozen silence beneath Europa's ice. We studied Titan's orange haze. And still, the biggest question remains unanswered. Are we alone? For thousands of years, humans looked up at the night sky and wondered if any of those tiny points of light had planets circling them. Worlds like ours. Worlds with oceans, mountains, storms, maybe even life. But for most of human history, that question was pure imagination. There was no way to prove it, no way to see that far, no way to know. Then, in 2009, NASA launched a telescope with one mission so ambitious it sounded almost impossible: to stare at a tiny patch of the Milky Way and hunt for hidden worlds, one by one. Not giant gas monsters, not blazing stars. Worlds, places, possible second Earths. That telescope was named Kepler, after the man who first figured out how planets move around stars 400 years ago. And what Kepler the telescope would go on to find didn't just answer old questions, it rewrote everything we thought we knew about our place in the universe. Kepler didn't work the way most people imagine a telescope working. It didn't zoom in and snap a photograph the way your phone camera does. Distant planets are far too small, far too dim, and far too close to their blinding host stars for that kind of direct picture to work. Instead, Kepler used a method so clever it almost sounds like a magic trick. It stared at over 150,000 stars at once, all in a single patch of sky, and it watched for the tiniest flicker. A dip in brightness so small it was like trying to notice a fly walking across a floodlight from miles away. That flicker happens when a planet passes directly in front of its star, blocking a sliver of its light for a few hours. Astronomers call this a transit, and by measuring exactly how much light dims, how often it happens, and how long it lasts, scientists could calculate the size of a planet, how long its year is, and roughly how far it sits from its sun. It was patient, mathematical, almost invisible work, but it was real, and it worked far better than anyone expected. Within its first few months of operation, Kepler was already finding candidates, small dips in starlight that hinted at planets no one had ever seen before. By the time its primary mission wrapped up, Kepler had stared at the same patch of sky for years, collecting an ocean of data. Scientists back on Earth spent that time combing through the light curves, separating real planets from false alarms, confirming discovery after discovery. The numbers that came out of that mission are staggering. Kepler is responsible for finding thousands of exoplanet candidates, and more than 2,500 of those have been confirmed as real planets. Before Kepler, astronomers knew of a few hundred planets beyond our solar system. After Kepler, that number exploded into the thousands, and scientists began to realize something remarkable. Planets are not rare, they are everywhere. Our galaxy alone may contain more planets than stars. And among all of those discoveries, some stood out. Worlds orbiting two suns at once, casting double shadows across their landscapes. Worlds locked so close to their stars that a year lasts only a few days. Worlds bathed in the deep red light of dying stars. Kepler even found planets in what scientists call the habitable zone, that narrow band of distance from a star where temperatures could allow liquid water to exist on a planet's surface. Not too hot, not too cold, just right. The way fairy tales describe porridge, except this time the stakes were the possibility of life itself. One of Kepler's most famous discoveries was a planet catalogued as Kepler 452b. Astronomers nicknamed it Earth's cousin. It orbits a star remarkably similar to our own sun, sitting inside that habitable zone with a size only slightly larger than Earth's. It isn't a confirmed twin. We don't know what its surface looks like, what its atmosphere contains, or whether anything lives there, but it stands as proof that planets resembling our own, circling stars resembling our own, are out there. Not science fiction, not speculation. Measured, calculated, confirmed. Kepler didn't stop there. It found an entire system now known as Kepler 186, home to 5 planets, circling a small, dim red dwarf star. The outermost of those 5, Kepler 186f, holds a special place in the history books. It was the first planet close to Earth's size ever found, sitting inside the habitable zone of its star. Scientists estimate it receives roughly the same amount of energy from its star that Earth receives in the late afternoon, just before sunset. A world permanently bathed in the soft orange light of dusk. No one knows if it has an atmosphere thick enough to hold warmth, or oceans, or anything resembling weather, but its existence alone shifted the conversation. It proved that small, rocky, potentially temperate worlds are not some rare cosmic accident. They are a normal part of how planetary systems form. Then there is the Kepler 442 system and Kepler 62, both containing multiple planets sitting in or near their habitable zones. Some of these worlds are what scientists call super-Earths, slightly larger and more massive than our own planet, with surface gravity that would feel heavier underfoot, but still, in theory, capable of holding liquid water. Others are smaller, closer in size to Earth, orbiting stars, cooler and dimmer than our sun. Each one of these discoveries added another data point to a growing picture. A picture showing that the ingredients for potentially habitable worlds, the right size, the right temperature, the right distance from a star, are scattered across the galaxy in far greater numbers than anyone expected before Kepler launched. Kepler also revealed something strange and unexpected about the kinds of planets that exist. Our own solar system has small rocky worlds close to the sun, and large gas giants farther out, with nothing quite in between. But Kepler found that the most common type of planet in the galaxy is something we don't have any example of here at home. A world larger than Earth, but smaller than Neptune, sometimes called a super-Earth, sometimes called a mini-Neptune. These in-between worlds turned out to be everywhere, forcing G scientists to rethink their models of how planets form and what an average solar system actually looks like. Our own neighborhood, it turns out, might be the unusual one. Kepler's story wasn't without struggle. In 2013, 4 years into its mission, a mechanical failure crippled the spacecraft's ability to stay perfectly still and pointed at its target. 2 of its 4 reaction wheels, the devices that kept it steady, broke down. For a moment, it looked like the mission might be over. But NASA engineers didn't give up. They devised a new way to stabilize the telescope using sunlight pressure itself, balancing the spacecraft against the gentle push of photons streaming from the sun. This clever fix gave Kepler a second life, a new mission phase called K-Tezu, letting it continue hunting for planets across new patches of sky for several more years. Eventually, in 2018, after 9 years of service far longer than its original planned mission, Kepler ran out of fuel. NASA made the decision to retire the spacecraft, leaving it drifting safely in orbit around the sun. Its final transmissions were confirmations of more distant worlds, one last gift from a telescope that had spent nearly a decade quietly rewriting the textbooks of astronomy. But Kepler's greatest legacy isn't just the raw number of planets it found. It's the perspective it gave us. Before Kepler, the idea of other Earths was mostly philosophical. A nice thought, but unproven. After Kepler, we had real numbers, real statistics. Scientists could finally estimate how many Earth-sized planets might exist in the habitable zones of sun-like stars across our galaxy. And those estimates suggest billions of possibility worlds, billions of possible chances for water, weather, chemistry, maybe even biology, to unfold exactly like it did here. That raises the question that has driven so much of this search from the very beginning. If there are that many planets out there, why haven't we found any clear sign of life? Scientists call this puzzle the Fermi paradox, named after physicist Enrico Fermi, who once asked a simple but haunting question during a lunchtime conversation with colleagues. If the universe is so vast and so old, and if planets are so common, then where is everybody? There are a few possible answers. Maybe life is common, but intelligent life capable of building technology is incredibly rare. Maybe civilizations do arise, but they tend to destroy themselves or fade out long before they can reach across interstellar distances. Maybe the vast gulfs of space and time between stars make contact nearly impossible, even if life is everywhere. Or maybe we simply haven't looked hard enough yet, and the discoveries that will answer this question are still waiting for the next generation of telescopes to find them. Some scientists point to something called the Great Filter, an idea that suggests there may be one or more nearly impossible barriers that life has to cross on its way from simple chemistry to a spacefaring civilization. Maybe that filter is the jump from single-celled life to complex multicellular life, a leap that took billions of years on Earth and might rarely happen at all elsewhere. Maybe the filter lies ahead of us instead of behind us, some future technological or environmental catastrophe that ends civilizations before they can spread beyond their home planet. It's a sobering thought, one that turns the search for other worlds into something more than idle curiosity. It becomes a search for perspective on our own survival. Others take a more hopeful view. They point out that Kepler's data only covers a tiny sliver of our galaxy, a single patch of sky containing a fraction of the 100 billion or so stars the Milky Way holds. If Kepler found thousands of planet candidates in that Smayel sample, then the true number of planets across the entire galaxy could run into the hundreds of billions. Even if the odds of life arising on any one of them are extremely low, the sheer scale of the numbers involved means the odds of life existing somewhere out there could still be quite favorable. The universe is patient, and it is enormous. Kepler didn't need to find every planet to change the conversation. It just needed to prove the scale of what's out there. That next generation is already here. Kepler paved the way, but it wasn't built to study the atmospheres of these distant planets in detail. It could tell us a planet exists, its size and its orbit, But it couldn't tell us what the air on that planet is made of, or whether anything in that air might hint at biology. That job has fallen to newer instruments. The Transiting Exoplanet Survey Satellite, known as TESS, launched shortly after Kepler's retirement to scan the entire sky instead of just one patch, hunting for planets around the closest and brightest stars, ones bright enough for follow-up study. And then there's the James Webb Space Telescope, an instrument so sensitive it can begin to analyze the chemical fingerprints in the atmospheres of these worlds. By studying G, how starlight filters through a planet's atmosphere during a transit, scientists can detect the presence of gases like water vapor, carbon dioxide, methane, and potentially even more exotic combinations that could hint at biological activity. This is the frontier Kepler's discoveries made possible. We went from not knowing if other Earths existed, to knowing there are thousands of candidates, to now beginning to ask what those candidates might actually be like up close. Looking further ahead, space agencies are already designing missions built specifically to search for direct signs of life. Concepts for future telescopes aim to block out the blinding glare of a distant star well enough to capture actual light reflected off a small rocky planet in its habitable zone, then split that light apart to search for the specific chemical signatures associated with living processes. Oxygen alongside methane, for instance, is a combination that on Earth is maintained almost entirely by biology, since the two gases react and destroy each other unless something keeps replenishing them. Finding that same imbalance in the atmosphere of a distant world wouldn't be a photograph of an alien, but it might be the closest thing to proof we could hope for from thousands of light years away. It's worth pausing on just how strange and beautiful this whole endeavor really is. A civilization on one small blue planet orbiting an unremarkable yellow star on the edge of an ordinary spiral galaxy built a machine capable of detecting the shadow of another world trillions of miles away by measuring a change in light so slight it defies easy description. That is not a small thing. That is one of the great achievements of human curiosity. Kepler turned an ancient question, one asked by philosophers, poets, and stargazers for millennia, into a measurable scientific pursuit. It didn't answer whether we are alone, but it gave us the tools and the numbers to start answering it properly. Somewhere among the thousands of worlds Kepler catalogued, there might be a planet with oceans lapping against unfamiliar shores. There might be a planet where storms rage across skies under the light of two suns. There might, somewhere, be a planet where something is looking back up at its own night sky, wondering the very same thing we are. Kepler couldn't tell us which one, if any, holds an answer, but it told us, for the first time with real confidence, that the question is worth asking, because the numbers say the worlds are out there, billions of them, waiting. And maybe that is Kepler's true legacy. Not a single dramatic photograph of another Earth, but something quieter and, in its own way, more powerful. Proof written in the flickering G-light of distant stars that our solar system is not unique, that planets like ours are common, and that somewhere in that vast, dark ocean of stars, the story of another world may already be unfolding, waiting for us to learn how to read it